In this video, I'm going to show you how to make a simple dynamic array in C++. So what exactly is a dynamic array? Basic arrays, for example an array with a size of 5, will eventually fill up. You can continue to insert data into the array's elements, but once you try to access an array index greater than that array's size, you will encounter an error, your program will crash, and no data will be inserted at that position. This is where dynamic arrays come in. Dynamic arrays get their name because they dynamically allocate new memory when the need arises. So, when inserting new data into a dynamic array, if the array is full, a new, larger array will be created. Each element of the previous array will be copied over, and then the old array will be deleted. This allows you to continue adding new data to the array without worrying about its size. After creating this dynamic array, we will be comparing our results of our dynamic array to C++'s built-in dynamic array called vector. So let's get into it. Let's start off by creating a new empty C++ project. Name it and save it to your desired location. Once that loads up, let's create a new header file. I'll call my header file dynamicarray.h. I like to start off by getting rid of the pragma_once tag and replacing it with if_and_if dynamic array, and under that define dynamic array. You will also need to write and_if at the end. Pretty much all this does is protects your program from instantiating more than one of these header files. Now let's create our class dynamic array. Now, in order to be like C++'s built-in dynamic array vector, our dynamic array needs to be able to store any data type. So how do we do this? By creating a template. So, above this class, we need to write template, and then type name, which we'll call t. Next, let's fill out everything we'll need for the header file. In this tutorial, I want to keep this dynamic array basic. So what will we need? In the public section, we'll need a constructor. And since we are dynamically allocating memory, we'll need a destructor as well. Now, we need 5 methods to get this working. We'll need a way to insert new data, which we'll call pushBack. This will also have a companion method called Reallocate, which I'll go over a bit later. Then, we'll need a way to access the size of the array, or the amount of currently used elements. We'll need a way to access the capacity of the array, or the amount of total elements in the array. And lastly, we'll need a method to access a specified area index, which we will call at. We'll also need to include 4 member variables. We'll need a pointer to the array so that we can actually access it. I'll call that array pointer, and it is a type of whatever type is passed in upon creation. Next, we'll need an int called maxCap, short for max capacity. Then another int called used, and lastly a static constant int called initial capacity, which I'll default to 2. Now that our header is complete, I'd usually begin to implement each method in a .cpp file, but when using templates, there's linking issues involved in this. I won't get too much into it, so instead of implementing the methods in a .cpp, we'll just implement them right here in the .h file. Let's start off with the constructor. Visual Studio makes writing these methods very easy. If we right-click on the method we want to define, we can choose one of 2 options. We can create a definition, and it will place the definition in its appropriate place, or we can copy the signature of the definition into our clipboard, and manually place it where we want it. I prefer to do it this way, but do it whatever way you'd like best. Now, paste your signature wherever you want it. I want it right after the end of the class prototype, as you can see. This puts the same template, type name t, line above the definition. All methods in the class will have this above them so that they know they are part of a template. I also remove inline from the beginning of the definition. That is simply a personal preference, but there are reasons to include it and reasons not to. I'll include a link in the description if you want to learn more about inline functions. So what do we need for the constructor? First, we need to create a new array and have our array pointer point to it. This new array needs to be created with the static variable we created called initial capacity. That way, all dynamic arrays that we create will start at this size. Second, we need to default used to 0 because there are currently no elements being used. Lastly, we need to default the max cap to initial capacity so that max cap is the correct size. Now onto the destructor. Let's copy the signature, then paste it below the constructor. This destructor is very simple. All it needs to do is delete the array, which is being pointed to by array pointer. So we just have to write delete with some brackets and array pointer. Next, let's write the pushback method. Pushback takes a constant reference to a given type called new data. This new data needs to be pushed or inserted onto the end of the array, but what if the array is full? We'll need to call reallocate in that case. Once the array is reallocated, we are safe to insert the new data onto the array, so we do it like so. You can save a line here by putting used ++ inside the brackets, since this is using a post increment. Let's now move to the reallocate method, since we are using it in pushback. The reallocate is the most complicated method we'll be using in this basic dynamic array. The first thing that reallocate needs to do is check if the amount of used elements is greater than or equal to the current capacity of the array, like so. If it is, we must create a new array. We want this new array to be bigger than the older array, so why not double its size? Let's create a temporary array pointer called temp_array and pass in this new max cap as the size. Then, let's loop through the old array, copying each of its elements to the new array. Now that it contains all the old elements, let's delete the old array and set the array pointer to this new array so that we can reference it. And that is it for the reallocate method. The next three are extremely simple. Size simply returns used. Capacity returns max cap. And @ takes in an index and returns the data at said index. Now let's create a quick driver for this so that we can test it. Ctrl+Shift+A to create a new file, and let's make a .cpp file called main. Let's include iostream and vector, and our .h file. Let's also use namespace std. Now inside of main, I want to create both our dynamic array as well as a vector, both of type int. Then, I want to push on several numbers. It doesn't matter what they are. Then create a for loop that loops through and prints the dynamic array using our .size method and the .at method. Lastly, I want to print out the capacity of our array using the .capacity method. If everything was written correctly, you can copy all of this and replace the variable referencing our dynamic array and replace it with the variable referencing the vector. Let's run it and see if it works. And like it should, it works just as intended. The capacities might be a bit different, but that is just because a vector might reallocate slightly different. However, the ideas are still the same. Thank you for watching this video, and I hope it helps you understand dynamic arrays a little bit better. I plan to go a little bit more in depth on dynamic arrays in the next video, so keep your eyes open for that. Thank you.